here's the graph of the fruit fly population from section 1.4. So we actually did this exact graph in our notes. So we talked about how fruit flies like get really exponentially fast, and then it sort of tears off. So it's almost like bacteria and illness. Like you get sick really quick, and then it tears off. And then antibiotics are like the opposite. You take them, you feel better really quick, but you have to take them for 10 days to get rid of the lingering virus. And then people who forget to take them get sick again. So on approximately what day did the population's growth rate change from increasing to decreasing? So what we are looking for is where is the point of inflection? Because the point of inflection is going to be where the graph changes from increase to decrease. So right in there. Hence day. They said day 24. I probably would have picked 25 because I picked the point on the line. But any between quarter doesn't make more sense. Awesome. So mean value theorem. The mean value theorem says that f of x is equal to x ln x. So I have to look at that, and the first thing I think in my head is, okay, well, x is continuous, but the ln of x is not. I know that ln does not live in the negatives. So already in my head, I have a domain in mind. So then I read part A, and it says, show that f satisfies the hypothesis of the mean value theorem on the interval 0.5 to 3. So I'm like, all right, good, I'm happy. No zero, no worrying about it. So that means that I need to say, okay, f of x is continuous, which it is. We know that natural log is continuous. We know that x is continuous, and we know that they're both continuous greater than or equal to 0. So f is continuous. Part A of mean value theorem is a check. Part B, f of x is differentiable. So again, I know that the natural log is differentiable everywhere except at x equals 0, because the derivative of natural log is 1 over x. So differentiable everywhere except at 0. Not in my interval again, because we're going 0.5 to 3. So check and check. So then by MVT, my function is continuous and differentiable, therefore MVT can be applied. So it said show that f satisfies the hypothesis, and it does. So then the next part is, what is its derivative? So part B says find the values of c in the open interval AB, for which f prime of c equals f of b minus f of a all over b minus a, which is the mean value theorem. So I need f prime of c, so that's the first times derivative of the second plus the second times derivative of the first. What's super duper nice is what is x times 1 over x? 1. So now I get 1 plus ln c. So then that's my derivative. Now I need to use a and b in the original, and I need to find the slope of the secant. So f of 3 minus f of 1/2 over 3 minus 1/2 equals 3 ln 3 minus 1/2 ln 1/2 all over 2.5. And again, they didn't come outright and say it, but it's a calculator question. Because I know the ln of 3. So at this point in time, I'm going to my calculator. Like, I can't do this math by hand anymore. I need my calculator. So on my calculator, I am putting this in y1, and I am putting this in y2. So if I put 1 in y1 and 1 in y2, I am looking for their points of intersection from point 5 to 3. Oh, good. I know you two are trying it. Do you want me to show you on my calculator? I just wanted to know. You asked me for 37. So do you need to see it on the calculator? But that's what I mean. Like, are you like? So I know they're trying it. So again, like I gave you the hint before, I would change my x min and my x max before I like let the whole thing graph, and I would make them 0.5 to 3 because you don't need or want to care about anything else. If you graph in zoom 6, you're negative 10 to 10, and like you don't need that. All right, and did we get 1.579? Woo! So the C value is 1.579. That value represents the point in the interval that the slope of the secant is equal to the slope of the tangent. And then
I saw that there was like LN's 19 years
like you turn subtraction to division. Yeah, the textbook actually changed subtraction to division. Square root of 0.5. Well, like, oh yeah, the y1, y2a is way better.
I like that. I use that when I do the
Why do math you don't need to do? That's like my thing all the time. It's like if there's an easier way to do something, let's do it. All right, 37C, write in slope-intercept form an equation for the secant line. So the secant line of AF of A and BF of B meant that we needed to find the slope of this. So you just needed to type that into your calculator, and that gave you a slope of 1.457, and then you just picked any of your points, like either one, and it was like y minus ln 3 ln 3 equals that slope and this. The only thing is the slope of this and that number are not the same. And then 37D was just like write it in slope-intercept form. So if the line is going to be tangent, then same slope, and then this is your y-intercept, because that's the point that it goes through. That's all. 39a was -1 plus 0, x minus 0 equals a -1. So 39a was -1. 39b is -1. And 39c is, okay, is this an over or under approximation based on that graph? So again, sine of x squared, you're looking at the concavity of that and in that quadrant, whether it was positive or negative. And in this case, the approximation is going to be an over approximation because the derivative would be positive. If the derivative is positive, then we have an increasing function and it is over approximation. The differential was dy equals -x squared e to the negative x plus 2x e to the negative x. So -x squared e to the negative x plus 2x e to the negative x. You could have also factored out your e to the negative x. And then times dx. Because it's a differential, you need to have it dy equals all of that and you multiply by dx on the other side. And then part B, we plugged in our numbers and our final answer was 0.01 e to the -1. Giving us C40. And then 46. So I know we asked for 46. 46 is the storage bin. So it's a optimization problem. And it says, find the dimensions of the largest open top box storage bin. So for me, open top box tells me a couple things. It tells me that this is not part of the bin. So when I think of that bin as being open and laying flat, it has a base and 4 sides. So if it had a top, then I would have an extra piece here. But no top, no piece there. So it says find the dimensions of the largest open top storage bin with a square base. So now that means this and this and this and this are all x. So this is x, this is x. So if I'm talking about volume or surface area, my bottom is x by x. And then it says that a vertical side, and that's just going to be, I'm just going to use y. So in this case, volume would be x squared y. Each side is going to be 4xy in terms of area, because each side would have an area of xy, and there are 4 of them. So my surface area is 4xy, and then I have one area of the square on the bottom, which would be x squared. So automatically, like, I obviously didn't even read the rest of the problem, but that's what I'm doing in my head. That's why I said it's so important sometimes to construct that image, because if I know what I'm looking at, then I can think about it. So it said you were looking for the dimensions of the largest open top storage bin. So we're trying to get the largest area. It has a square base and vertical sides that can be made from 108 feet squared of sheet metal. So that's squared. So that's surface area. So the information I'm given is SA. So what I want to do at this point is solve for the variable y. Because I don't want two variables in my problem. So y is 108 minus x squared all over 4x. And I'm going to take that y and put it into the formula I'm optimizing, which is volume. Coefficient or a constant, you don't have to do the quotient rule with this one. So I broke it into like two pieces because now when I take my derivative, like 108 divided by 4 and 1/4 are a lot easier to take derivative of. Does that make sense? So the derivative of 108 divided by 4, which also simplifies kind of nicely. So 4 goes into 108 22 times. Sometimes 4 is 8. It makes me nervous. I'm going to say I think it's wrong. I think I'm off by yeah. So I said I didn't account for that too. I just said 22. Wait, come on. So it's 27x. So the derivative of 27x is 27 minus 1/4 times 3x squared. So now you just set that equal to 0. And I get x equals 6. So the base is 6 by 6, and then its height would come from taking that 6 and plugging it back in here for y. So you'd have 108 minus 36 all over 20. Better? My aunt is Alex Silvers. All right, 52. So 52 is a cost problem. And and that's the one that was on the second part of our test. So cost is what you're deriving. So in 52, the problem said a drilling rig 12 miles offshore is to be connected by a pipe to a refinery onshore 20 miles down the coast from the rig as shown in the figure. So they gave you all the information. They told you how to set it up because they gave you that drawing. And then it says if the underwater pipe costs $40,000 and the land-based pipe costs $30,000, what values of X and Y give the least expensive connection? So the very first thing we have to do is create our relationship. Then we need to put the cost in. So that's what happened on our test the other day. We created the relationship, derived the relationship, and applied the cost after. But since we're trying to minimize costs, we have to apply the cost before we take the derivative. So let's get that drawing as a relationship. So they made X the diagonal, which is annoying to me, 12 here, Y here, and then Y 20 minus Y there. And what they said is that what was under water is the X value. So the X value is like your underwater part of the material, because you're going from the rig to the shore, and then the shore is the 20 minus Y. So underwater pipe is 40, land pipe is 30. So we know that the total length of this has to come into play. So we need to create that relationship, or we need to be able to have an idea of what it's going to look like. So X is 40. Y is 30. And then we're going to say that the Y piece we need, hate all this, is 20 minus. So like this and this are only going to come into play when it comes down to making my like Pythagorean triangle. They're not needed really in my problem. So now we are going to clean that up. Like I would distribute. And again, this is where you have to say, okay, how do I get rid of one variable with the other? So did we try to get rid of X, or did you try to get rid of Y? Anybody like try it? Get rid of Y? I think I would also get rid of Y. Just based on the fact that I don't want that 20 minus Y. So I'm going to try to get rid of Y. So what I would do is come up with a relationship between X and Y using Pythagorean. So X squared is equal to 12 squared plus Y squared. So then if I'm getting rid of Y, I'm going to solve this for Y. So I'm going to substitute that in. to go to my calculator. Because again, you're just minimizing costs, and I mean, well, you can do it without a calculator if it's nice square roots, but that's worse. Because really what's going to happen is you're going to have 40,000 equals 30,000 over, or no, x, sorry, over x squared minus 1. So then the x squared minus 144 and the 40,000 will flip, and like all those are going to cancel. So you're going to have and like square those sides, subtract, move over, and multiply. But this would be a calculator problem for me because the 20,000s and the 40,000s and all those big numbers are just gross. And the cost functions are typically in terms of dollar amounts, so you're getting a calculator 2 decimals. But I feel like your textbook made this a non-calculator. Which is 12 times 4, which is 48. So it's 48. And then the y is all of that, under all of that. It's the y I can't do. Like the x I'm okay with. I can get that number. So that 48 over the square root of 7 is 18.14 miles, and then the y ends up becoming 36 over the square root of 7, which is 13.607 miles. If you use your calculator. I like it. Okay, that was 15. And then we talked about 67. So those are your two optimization problems. 67 is a, oh no, it is another optimization, isn't it? I think I tried to find you as many optimizations as I could.
Similar triangles and
yes.
stuff like that.
Yes.
And then I got to like where that was, and then I was just like, trying to derive it, and then.
So your similar triangles, did you have like a over 6? Equals a plus 20 over h. Perfect. Perfect. And then did you cross multiply? Okay. So I would have probably divided by a. So I had h solved for. So then when I set up my next equation, I could plug or like use h and a together. So I would have said that h equals 6 divided by a, so 6a over a is 6. And then this would have been plus 120 over a to the negative 1. And then you would just take your antiderivative because you wanted dh dt, dh. Find the height of the lamp is, use tan, blah, blah, blah. Find the measure 6-foot pole, 20-foot lamp, and measure the length of A, its shadow, finding it to be 15 feet, give or take an inch. Calculate the height of the lamppost using the value A equals 15, and then estimate the possible error.
So I got the measurements on page 8, because I got negative 120 over 8. That's the
Yeah. Well, it'd be DHDA, not DT. Because it's not, yeah, because it's not a related rate.
I was thinking it was like all related rate. I think that's what I had. So I was having to do
Yeah, you don't need, it's not a related rate because nothing's moving. Since nothing's moving, exactly. So you're trying to find the max length of the shadow, or the height of the shadow. Like, no, max length of the height of the lamp, because the shadow could be 15 give or take. So it's kind of like
I was thinking of the one that we did like in our
with the man walking.
Yeah.
Yes. And I think when I saw this, I thought that's what it was going to be. But now that I read it, as a lie. It's not. It's DHDA, because then you get negative 120 over A squared, and then they told you A is like 15-ish. So you just plug that in and simplify. And it's like negative 120. So that's your percent error. Because
that's your percent error. So
that's like what it can be a little bit bigger or a little bit
So I
smaller.
was thinking you had to like find like the real like the.
So the real height would come from this.
Okay.
You would plug 15 in there, and it'd be like 6 plus 120 over 15, which is 120 over 15. I'm thinking. I was gonna say, I feel like it's a nice number, so 14. See, I was gonna guess 14, and I was like, And then this represents like the movement forward or backwards from 14. So it's like saying if the length of my arms is supposed to be approximately my height, but there's an error that goes to it. So it's kind of like a stats question. It's like the bullcrap stuff that like it's like made up math in a way, but it's like your percent error. It goes back to chemistry, right? Like not every mixture is going to be measured perfectly because you have the error of like what stays in the beaker or not. That's what the DHDA represent. It represents like the measurement error.
So I was thinking it was gonna be like because like you were gonna have like a certain height minus like that. I thought that was it.
I thought it was going to be a related rate. It is not. It is a lie. Because the object never moved. Like if that object moved, I mean, the textbook tricked me with that image. I saw the image and I was like, yes! A triangle related rate. Alright, the answers to 70A was 2 pi r dr dt, which turned to 4 5/3 inches squared. Part B's answer was 1 inch per second, and C's answer was 4 5/3 inches squared per inches, which is just inches. And then you said 71. I kind of knew 71 was going to be a little tricky, but you know, I like cylinders. So it says a piece of wire is 60 inches long and is cut into 6 sections. So for me, I'm drawing out my wire, thinking, okay, it's 60 inches long, cut into 6 sections of 10. Boom. 10. 2 of length A and 4 of length B. So I'm like, all right, A, B, 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 B. Each of the two sections of length A are bent to form a circle. Circle, circle. So that means the circumference of my circle 2 pi r is A. So A is 2 pi r. And the circles are joined by the 4 sections of length B to make a frame for a model of a right circular cylinder. B is my height. That's it. It's just that you need the height 4 times to hold the cylinder up. So that means that surface area of the cylinder of that rectangle shape is A by B. It's like the rectangle that would hold up that cylinder is A times B. It's just that you have 4 B's and 2 A's. So that's kind of like what's happening. Those B's aren't actual rectangles, it's lines. Okay? And then it says, find the values of A and B that will make the cylinder of maximum volume. So again, optimization, right? Like you're trying to maximize the volume of the cylinder. So volume of a cylinder is pi r squared h. But now you have to take into account that 60. And that's where it becomes a little bit tricky, right? So we know the volume of our cylinder, and we kind of know the relationship here. So H is going to become B. Circumference is 2 pi r. So I could go and solve for r using A, because I can say that r is equal to A over 2 pi, and I'm just going to square that. So that gives me A squared over 4 pi squared. But then I don't like pi squareds, but I notice I have a pi up here, so I'm going to cancel that pi and cancel the square. So my volume ends up becoming all this. But then what's my problem? I have 2 variables. So the easier variable to get rid of, in this case, once I've done all that plugging in, is B. And I'm going to get rid of B by using the idea that I know how long that whole piece of string is. That whole piece of string is 60. So 60 equals 2A plus 4B. So B is equal to 60 minus 2A all over 4. 60 divided by 4 is 15. And then 2A divided by 4 is 1/2. And then I'm going to use that in my volume. And now at this point I'm trying to maximize. So how do you maximize? You derive. So we're going to take the derivative of that. And honestly, I would probably distribute the a squared. So I had 15a squared over 4 pi minus a cubed over 8 pi. And I'd say that my derivative then became 30a over 4 pi minus 3a squared over 8 pi. And the reason I didn't simplify them is because they don't technically have like denominators right now. So I didn't even simplify my 30 and my 4, because what I'm going to do is actually multiply this by 2 so that I have 60 and 8. so that I can take into account that the denominator like means absolutely nothing. And that I need 60a to equal 3a squared. I'm going to set the numerator equal to 0, and I'm only running out of board space, so I'm kind of cheating a little. And then I'm going to say, I mean, technically, it's 3a squared minus 60a, so you can do it this way, where you factor out the a and 3, giving you a minus 20, but eventually we know that doesn't matter. I'm getting this one. So then you can find b by saying, okay, well, 40 is a, 60 minus 40 is 20, 20 divided by 4 is e5. Was that better though? Like, do we understand it a little more? Was it really the drawing that was throwing us off? Like, what was a little confused? Just their wordings, maybe?
I was confused by like taking the wires mix. That's why I was like, I was picturing like how I put I was like, how is that?
So like, yeah, exactly. Like sometimes just like the way I drew it kind of is helpful. And then part B said use differentials to justify your answer in part A. So the differential would be the derivative of volume. Like this is kind of back to like that lamppost one. It'd be dVdA. So here, dVdA, I'm so out of dVdA would still be equal to that this right here, or you could even do it my simplified 60a minus 3a squared over 8pi. So then your differential, you would multiply both sides by dA, and you would say dV so there's your differential, and then just to prove it's a max, you would do like your other one. But that's all they're looking for is what's the differential. And that is all, my dear friends.